Hello, this is Math 2-115, Discrete Mathematics, coming to you from the College of DuPage for the term Fall 2020, and this lecture is entitled Course Specifics, an Introduction. Catalog description says, students will be introduced to the formal study of discrete structures in mathematics. Topics include set theory, combinatorial mathematics, logic, graph theory, Boolean algebra, and formal languages. More generally, discrete mathematics is the study of mathematical structures that are discrete rather than continuous. So in contrast to real numbers that have the property of varying smoothly, the average study in discrete mathematics, such as integers, graphs, and statements in logic, do not vary smoothly in the same way, but have distinct separated values. Discrete mathematics, therefore, excludes topics in continuous mathematics, such as calculus or Euclidean geometry. Discrete objects can often be enumerated by integers. More formally, discrete mathematics has been characterized as the branch of mathematics that deals with countable sets. These are either finite sets or sets with the same cardinality as the natural numbers. However, there is no exact definition of what discrete mathematics means. Indeed, discrete mathematics is described less by what is included rather than by what is excluded. Continuously varying quantities and related notions are excluded. Research in discrete mathematics increased recently due to the development of digital computers, which operate in discrete steps and store data in discrete bits. Concepts and notions from discrete mathematics are useful in studying and describing these objects and problems in branches of computer science and computer algorithms, programming language, cryptography, automated theorem proving, and software development. Conversely, computer implications are significant in applying ideas from discrete mathematics to real-world problems, such as in operations research. So, we have a bunch of learning objectives. These are the global learning objectives. Upon successful completion of this course, students should be able to do the following things: define, construct, solve, determine, construct, translate, and design. And we will be doing some proofs, which is different for some students. We're doing a lot of things with combinatorial calculations. We'll be studying graph theory and Boolean algebras, and so on and so forth. The course will include, but not be restricted to, the following topics. And you can see we'll talk about set theory, functions and relations. We'll talk about a technique of proof called mathematical induction, combinatorial mathematics, graph theory. There's 3 items dealing with graph theory, logic and Boolean algebra, and sequential circuits and finite state machines. This is our course, and it is called NET, N-E-T. That means that it's delivered in the following way. NET, N-E-T, stands for Online Asynchronous. This instructional mode allows the students to engage in the class at any time of the day, so long as certain deadlines for the completion of work are met. Asynchronous courses typically rely on tools such as pre-recorded lectures and discussion forums. It is especially appropriate for students who need increased flexibility with their schedules. Interaction within the class can be accomplished through discussion boards, emails, and other means. An asynchronous class can be self-paced, but also has deadlines. We will have deadlines. NET implementation also provides increased flexibility for the instructor, and I am very prone to exercise this flexibility. So lectures will be posted at various times and announced via course announcements and email. Although I will strive not to abuse this privilege, students must understand it is incumbent on them to pay strict attention to these notices and the information contained in these notices. This is known as the academic calendar. We'll start on the 24th of August and we'll finish before the 18th of December. And many things happen in between. This includes some holidays and so on and so forth. This is less important for NET offerings because you can study math whether the class meets or not, but some deadlines still will apply. So be familiar with these. For example, the last day to withdraw from this course will be here. Similarly, this is the final exam schedule, but this only applies to Not NET courses, but VCM courses, virtual classroom meetings, which meet at a specific time. So it's pretty much irrelevant for our course offering. Again, we will begin on this day, and we will finish on during this week here. And tentative targets for our midterm exam will be October 14th, and for the final exam, December 15th. I am still negotiating these with the testing center, so stay tuned for updates. These are targets or stakes in the sand. This is our primary textbook. I will use other references. It is Johnson Bow, Prentice Hall, copyright 2017. This is the 8th edition, and these are the areas that we will cover. I may cover more. Some people rent these books, some buy ebooks, and some get them just fine using in-class notes. You will not be harmed if you wait a bit before making such a decision, but homework will be assigned from this course book. And so, we're ready to begin our journey together. The road will be long, but I think it's pretty straight. Some of it will be uphill, but we're working towards a valuable goal. So, in closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other. God bless you all.